Yeah. So, Dr. Zoe, thank you very much for accepting the invitation. I will make you the host now. Just a moment. So, feel free. So you're the host now. The
Yes,
stage
I'm the
is
host
yours.
now.
So you can share your screen and go on.
Okay, let me try to share my screen and try to share my PowerPoint. I just wonder, are you seeing my PowerPoint okay?
Yes, it's perfect.
Okay, that's
So
great.
I'll disappear, but I'm still here.
Thank you. First of all, thank you very much, Dr. Lopez, for your kind invitation to invite me to join this wonderful AI seminar series organized by NCCHD. Today, I have prepared about 40 to 45 minutes, I guess, presentation regarding to our AI for patient safety research study. I guess to begin with, I would just like to mention that this work has been a close collaboration between our AI for patient safety team from the patient safety policy maker point of view, as well as NLP researcher, as well as health informatician, and so on. So it is not possible without our partners' contribution as well as support. And of course, it is also important to have funding support from the JSPS. We obtained JSPS funding for this work previously. So I guess to begin with, I would just like to give you a brief summary or brief introduction about myself. Although Dr. Lopez has already gave a very nice introduction about myself, I guess it's okay to spend 1 to 2 minutes to talk about myself as well. So as Dr. Lopez mentioned, I'm currently an associate professor at St. Luke's International University. I'm affiliated in the Division of Biostatistics and Bioinformatics area in the Graduate School of Public Health in St. Luke's International University. As you might know, we are offering MPH and DRP the PhD program to public health students. I'm currently teaching health informatics, infectious disease modeling, and DRPH seminar in the school. In terms of my research areas, I'm interested in NLP method. For those who are newcomer to maybe NLP is natural language processing. I'm going to tell you more about NLP a little bit later as well. So I'm interested in applying NLP method in medical field, AI perfect for patient safety, as well as digital communication for infectious diseases area. In terms of my e-health community outreach, I'm currently an associate editor for NPJ Digital Medicine. I was the guest editor for some IJMI2 special issues on evaluating digital health area. I am also participating in EMEA working group on evaluation work group since year 2017. I'm currently serving as an academic advisor for a WHO dashboard development project, and so on. So in terms of our talk today, I would just like to I would like to give you an overview about the talk. So I guess maybe the first 10 minutes, I would like to talk about some background information as well as background research on clinical NLP. I knew that some of you might come from hospital background, so maybe this is a new field for you. So maybe through this part, you will be able to understand a little bit more on what is clinical NLP. And second part, that would be the main of our presentation today. I will focus on our AI for patient safety work. So the work actually is like a series of work that focusing on how to improve patient safety in terms of medication error using AI methodology. So what we have done in the past, including developing annotation method tailor-made for a specific type of free text incidents, and we develop AI model scale for the special framework on the annotation method, and we develop digital tools in order to connect the hospital user with the AI method that is able to empower them to learn better through the methodology. And finally, I'm going to talk about a little bit more about maybe like future directions as well as the future challenges and so on. I hope I would not. I hope I can keep you entertained in this short period of time today. So I guess to begin with, I would like to talk about some background issue that you might have come across every day. As many of you may be working closely with hospital, you will know that actually free text has been a key format in terms of collecting information from hospital setting. Clinical narrative actually it contains significant portions of EHR information, and it has been in free text format. The types of free text electronic digitalized documentation in healthcare setting, including, for example, discharge summary, procedure notes, physician progress notes, laboratory report, physician order, and so on. These kind of free text information are actually extremely rich in terms of the information collected from hospital. But at the moment, actually, we are only using in a very superficial way, or not even using this kind of information. So my research interest is how could we make use of NLP method to extract information from potentially usable free text information. Challenge is really challenging. For example, some of these documents are interlinking with each other, and being able to capture information among different types of free text information is actually essential to support the subsequent step that you are aiming to achieve. So, but I believe this is the future of healthcare. I might be biased because I've been spending my time on NLP for clinical studies. But maybe you will ask one simple question. If you are new to this field, what is NLP? What is clinical NLP? Basically, NLP method, natural language processing method, is the application of computational technologies or computation techniques into the analysis and synthesis of natural language and speech. So basically, you need the free text data, and you will need to understand the linguistic format, linguistic structure of how particular types of people or types of language would address. You will need to make use of, for example, in the old days, we usually use rule-based or machine learning or AI-based method to empower you to extract information from free text. One more dimension that is very important is that because we are concerning or applying an NLP into clinical context, it has to be context sensitive. It has to be focused on what kind of subject matter you are interested. So I would say that clinical NLP actually has three major components: the linguistic, the nuances that people use language, the technology itself, how could we make use of the most advanced AI or NLP methodology in order to extract information more efficiently, as well as the clinical context that is relevant to the subject matter we are concerning. Essentially, we are hoping to teach programs to understand the contents of the document so that we could extract information efficiently. So it involves in computation linguistic, as well as we involved in understanding nuances, semantic and syntactic structure of text. So some common NLP challenges. Actually, I also took a look on the websites of ANCCHD. I know that actually bioinformatics area has been a very key focusing research area in the hospital. NLP, actually bioinformatics NLP has been really, really popular as well. But I myself actually work more on clinical NLP, but the methodology itself, I know that is highly relevant, including the core methodology we have been using. I knew that it has been using in biomedical context in terms of tagging genes and so on. So, but common NLP challenges or common NLP usage you have been seeing in daily life, actually, including, for example, Google Mail. Google Mail could automatically detect your spam mail and put it into a spam mail folder. So that would be like a kind of automatic document classification application. Or semantic analysis, we call it opinion mining. So some researcher actually will focus on mining Twitter data or Facebook data in order to understand how population like the tendency towards a certain subject, for example, polling on a certain politician or so on, semantic analysis. Other types of application actually has been quite useful, or maybe you are using it every day. Article writing or machine translation, you might be using Google Translate every day, and question answering and so on. Other applications you have been seeing a lot these days is speech recognition. So automatically algorithm could detect your conversation and put it into a free text format already. And conversational agent, chatbox application, or Google Home, like this kind of conversational agent that you could communicate with bidirectional flow of information between the user and the machine itself. Recommender system is also one of the very popular types of NLP application. So for example, when you browse Google, YouTube on certain types of video, automatically algorithm would provide you some relevant, maybe suitable for your interest videos. So these are other applications that we call it recommended system. One of the core challenge or core NLP tasks that is actually very essential and more like a backbone task is named entity recognition. So many of these NLP challenges are actually backed up by named entity recognition. So the idea itself is that so we want to teach algorithm to automatically identify terms of interest related to a predefined category. So for example, I want to identify all the patient name from a free text document. I want to identify all the company name. I want to identify all the drug name. So these we call it named entities. And actually this is a very important task. And with these tasks, you could subsequently train up or design ontology, which is the annotation method, to identify relationship between the tagged identified name entities. So for example, I'm here giving you an illustration that Letator is a kind of drug, and this drug would cause adverse drug events of fatigue. So these kind of relationship can be identified through ontology design, and we will be able to use algorithm to predict the relationship between name entities. And subsequently, you could imagine that once we could extract structured information from the free text, we will be able to put it in a table format, and we will be able to do a lot of analytic using structured information, using combination of these name entity and relationships. And of course, you will be able to design dashboard display in order to communicate with the hospital user, including the reporter or the policymaker, to provide some maybe projection or trend projection or historical review on past events. So these are all potential applications on NLP, and I believe these are very useful, and these are really, really important for the future of healthcare. In terms of NLP for clinical notes, actually, this is not totally not a new topic, and it has been really heavily studied, not really heavily studied, but I mean, group of researchers interested in clinical NLP. If you are interested in this direction, I would recommend you to take a look on N2C2, published by Harvard University. And every year they would announce like a kind of annotated data, as well as call for challenge, like different NLP team would try to use the gold standard data and achieve the best possible prediction outcome using the best available algorithm. So in terms of the clinical condition or the tasks they announced in the past, including the following list. For example, you could predict smoker or non-smoker using clinical tests. You could predict obesity or some health disease risk, or you could predict temporal order among different free text notes, predict symptom severity, or identify name entity recognition. So as I mentioned, name entity recognition is extremely useful. And one of the main application is on the identification. So you know that free text clinical notes always contain some patient name. So using algorithm, we could find patient name and automatically de-identify those parts as well. So these are possible application, and we have been using name entity recognition as well. But our goal for name entity recognition is to detect drug error related concepts, as well as relationship extraction, just like what I mentioned before. So these two tasks are actually very important, and we have been studying it quite a bit in the past several years as well. And we will also dedicated to continue to study along this line in the future as well. So just some background information. If you are new to NLP, these are some essential tasks that NLP can do. So for example, we could, with a free text, one whole paragraph, we could tokenize or chop it down into every single individual token. We could identify part of speech. We could do chunking. We could eliminate stop word. We could normalize wordings. But these are some basic methods. In terms of common techniques to detect medication error using NLP in the past, actually, researcher has been heavily using rule-based approach. So rule-based approach, actually, they more or less you identify trigger phase or rules. So trigger phase, for example, if you want to identify certain types of adverse drug events, you first of all identify types of keywords that is relevant to this kind of drug events, and then you set up rules in computational program. So whenever the, for example, whenever the free text report appear certain types of keywords, then this report will be taken out as a potential trigger on this is a potential document that we identify. Of course, this is not good enough. That's why researchers also explore different symbolic method. So symbolic method essentially focusing on exploring the syntax and semantic patterns surrounding drug concepts. So for example, you could use some rules or regular expression or certain structure of grammar to specify the presence of certain types of adverse drug events. Other level of study would be using ontology-based method. So we have been doing this as well. And the idea is that you design the whole concept map on how do you capture information from particular types of data, and you design the entire annotation methodology itself. So basically you need to identify whatever is a relationship to another concept. So for example, in here, for example, the leptin drug is causing adverse drug events of maybe coma or sickness and so on. So you need to identify this kind of ontology using the ontological approach. So with this, we could do a lot of programming, AI programming to do name entity recognition and relationship extraction. So I'm going to, up to this point, I'm going to talk a lot more about what we have been doing along the line on ontology design, AI modeling, and digital health tools development. So, but I guess to begin with, let me just tell you a little bit about the background of patient safety, and that's contribute to the reason why we have been focusing on incidents reporting types of data, as well as hopefully to provide learning resources to user through incidents reporting. So from WHO patient safety fact, we know that actually patient safety is a huge issue among the world. So it's been the 14th leading cause of global disease burden. 1 in 10 patients in high-income countries, they are harmed while receiving hospital care. And among all different types of incidents, medication error is actually potentially avoidable, and it is also the leading cause of healthcare error as well. So back to WHO, they recently, in year 2022, they have already announced a white paper action plan on global patient safety action. This is an upcoming 10 years goal. WHO is trying to mobilize global effort to achieve the goal that eliminate avoidable harm in healthcare. It has been arguing or criticizing that incident reporting system cannot really facilitate genuine learning in healthcare context. I believe so many hospital healthcare professionals, they have been doing incidents reporting all the time, but whether you can obtain genuine learning outcome through incidents reporting, this is a question even at this point of time. In terms of medication without harm, it was announced as a priority goal on patient safety as well. And these actually contribute to the reason why we have been focusing on this topic. And we believe that this is globally important topic that we hope using collaborative effort to achieve the target. In the action plan, WHO action plan, actually, they specifically talk about what kind of action we could do in order to achieve this global goal. One of the major action is to innovate patient safety incidents reporting and learning system, and we have been contributing to this direction. And with our earlier effort, we got some idea, and we hope that in the upcoming 3 to 5 years, we will be able to achieve this. In terms of incidents reporting, actually, WHO has provided a MIM-PS, minimum informational model for patient safety. And this is basically a reference structure to the world that how incident reports should be captured. So it has 2 major components: structured items, for example, sex, age, gender, incidence, location. These items are very easy to standardize and organize in a categorical format. It has no problem at all. But the core part of incident report remain in free text format. And basically, reporters will describe what happened regarding to the incidents, what caused the incidents, outcome, and action in the freestyle way. So this actually also comes with a lot of issues. So existing reporting system, I often hear from healthcare professionals, they comment that they have been spending a lot of effort in explaining what happened in the hospital. We are hoping to improve hospital safety, but we never know whether the effort is truly worthwhile, whether we are using this data effectively or not. Other issue is that it has been accumulating many reports, and it is impossible to effectively retrieve similar cases from millions of reports across different countries as well. Free text incidents without any analytical structure. We do not have an analytical structure on analyzing the free text format. And that is the reason why incidents report learning has been ineffective. It is not organized and require enormous human effort in order to do any historical review on certain types of incidents. So it has been a very huge challenge in this type of data. In terms of incidence reporting system across different countries, actually, you might know JQ, Japan Council for Quality Healthcare. We are partnering with researchers from JQ to use the JQ report to enable our study. In UK, you've got the NHS system. Australia, you've got the AIM system or Richmond system. Hong Kong, we got advanced air system. But these kind of systems basically a national system that collect incidence reports across all the affiliated hospitals. Individually, different hospitals also maintain their own system. For example, I believe they could also maintain their own internal incidence report system for the internal quality improvement. As you could imagine, these kind of data set actually has been like in a very huge collection and in narrative format, big data scale, waiting for some innovative method to retrieve the information as well as make further use. So our team effort on this direction, as I summarized before, we have been investigating on 3 different very different aspects, but these are very interconnected aspects. All of these are helping each other to go to next step or reinforcing the first step. So we designed custom-built ontology for incidence report. We developed AI method to learn from the ontologies, and we designed digital application in order to bridge the gap between digital health AI tools and hospital users. So in terms of the ontologies, basically we need to develop an annotation method that provide the rules to organize drug incidence, concept, and attributes. So essentially, we need to identify some essential name entities that is meaningful to medication error. And we also need to identify some meaningful attributes that is able to tell what kind of incidence it is, as well as tell the relationship among these name entities. We have been bear in mind a multi-language approach. So when we design this annotation guideline, we also think, okay, this is applying to Japanese context, whether this is going to apply in English context. So far in the first version of the annotation method, we find that it is highly relevant to other language usage. But in the upcoming future, we are going to develop the annotation method in a more language-specific approach. So we will see a lot of challenges, but hopefully we could bridge the challenge in order to solve a bigger problem in the world. So we basically tailor-make the annotation method. And the name entities that we concern with, including, for example, drug name, the form, the strength, duration, timing, frequency, date, dosage, route, wrong patient. So this is an example of what kind of name entities we are trying to look for. So for example, drug, it could be amidine or ibuprofen or any drug name. So we would identify all the drug name and as the category of drug and form, strength, and timing, and so on. Other part of after we identify name entities, we identify essential relationship between name entities as well. So one of the very important methods that we investigate and developed in our team is to identify the intention and actuality analysis. So basically, we try to identify the discrepancy between what is intended to provide and what is actually provided to the downstream operation. And we will be able to identify, through this, we will know whether this is an error event and what particular types of name entity occurred in terms of the error. So I want to give you a simple example here. This is the knowledge extraction rules, and you could see that this is a typical way how we write an incidence report. Loxapulphine, 1 tablet, 50 milligram, and verbamitide, 2 tablets, 100 milligram were prescribed, but it turns out Sanoside 2 tablets, 12 milligram was given. So as you could quickly identify, so Loxapulphine, Sanoside, verbamitide are drug. Dosage, 1 tablet, 2 tablets, and 2 tablets dosage. Strength amount, 50 milligram, 12 milligram, and so on. And then once you understand the context of this paragraph, you will know that actually Sennoside was given instead of Rabamitide, and that is actually the core of the error. So we will need to identify the error event here. So basically, we categorize it in terms of error intended and actual, or intended not actual, and not intended actual categories, so that we know that which one of these is error item and so on. So and in terms of this example, basically it's a wrong drug and wrong strength amount. Through this procedure, we will be able to deduce this incidence type. So we have published our annotation guideline on GitHub already, and then actually our paper is under consideration of journal consideration at the moment, and we have validated the medication annotation method through earlier study. Our team also do some rule-based approach to help us identify name entities, but I believe I might be running over time if I talk too much on rule-based. But with rule-based, it also enables us to understand more about the AI-based approach. So AI-based approach, essentially, we try to predict the class of every single token. So for example, you have the free text data, and the free text data, when it is annotated, it will be presented in the following format. See the bottom left format. So doctor is a person, prescribe is a procedure, deltism is a drug name, and so on. Instead is nothing. Okay, so in your training data set, basically you have this label already, and we train up AI model with essentially, it depends on the AI model, but basically 3 layers. Embedding layers is try to vectorize your input, your free text input in a vector format. And basically in the embedding layer, it will combine these vectors into a long string of computational code that no one will understand, only computer understand. And the encoding layer basically does the main task to learn from these vectors, and in order to do prediction. And on the prediction layer, decoding layer, it will predict in the new free text which category, which class does it belong to on every single token. So if you got a little bit idea on classification problem, you could see that this is essentially a multitask classification problem, but it predicts every single token in your free text. And by the way, we also do Japanese, we mainly do Japanese NLP, but we also do English NLP. The interesting thing is that the different language NLP actually is highly relevant with each other. So for example, we just need to add one embedding layer on Japanese relevant context in order to tokenize the free text. Then the rest of it basically would be essentially the same. The pipeline would be essentially the same. So it's highly transferable. So with this understanding and with the understanding of incidence report data, we have published a JAMA publication last year. It's an incidence report classification framework, which is essentially improve the classification efficiency of machine learning algorithms through resampling approaches. We talk about relationship extraction. So maybe I just briefly give you some idea on what we are doing. So once we identify the name entities, basically we need to identify some relationship between these name entities. You could, depending on your like kind of structure you want to impose, it could be a binary classification problem or multi-class classification problem. So you could set it up in your AI model. So you could predict whether these two, for example, bottom low figure, whether these two these two name entities belong to certain class or not certain class. And we could frame it in a binary classification problem or multi-class classification problem, and then we solve the relationship extraction issue. So as I mentioned, we have our own annotation guideline published, and we also published our gold standard annotated data using the free text report provided by JQ. And you could find our gold standard copies from this website, and we did an evaluation study on this gold standard data as well. And with gold standard data, actually subsequently we developed AI model, BERT model, to tailor-make for the problem we have. So essentially, we need to achieve name entity recognition and relationship extraction tasks. So first of all, we use a published BERT model, Japanese BERT model that was pre-trained on Japanese Wikipedia and Twitter data, and we pre-train this model using our incidence report unannotated free text, which is a quite large corpus on 121,000 free text data. And we fine-tune this model with two phases of annotated data. The first phase, we use the rule-based model to annotate the entire data set, and then we use the rule-based data, annotated data, to teach the BERT model. And on the second phase, we use the gold standard data we have published, and we basically teach the AI model again in order to let AI model become smarter. So it turns out we have a 3 separate BERT densely layer model for our complicated tasks. And so basically one single model achieved 3 different tasks already. With these machine annotator, we are able to annotate the entire corpus of medication error from incidence report from JQ. So we also published the largest corpus of annotated incidence report in the world. It is on GitHub already, and we submitted the paper for general consideration at the moment. Basically, the corpus consists of 58K structured medication error for incidence report. It encapsulates around 400,000 named entities. It's useful for future machine reading and machine knowledge extraction usage, because these data are also validated by ourselves as well. Here, I would just like to maybe give you some idea on the next phase we have been doing. So we, by the way, if you are interested in our research, you could feel free to take a look on our AI for patient safety website. We update our progress from time to time. And we have our system launched on Amazon Web Servers already. So this is the system we have at the moment. And you can see that we have 2 different language interface, English or Japanese. You could feel free to use Japanese if you feel like to, because our presentation is in English, so I guess I will keep it in the English interface. So what this system does is to try to streamline or try to provide a proof of concept on how could we innovate incidence reporting process into a more assisted learning approach. So basically the purpose is to facilitate learning through incidence reporting. And what the system do basically automatically structure incidence report using the format we described before. And we automatically recommend learning resources to user using simple algorithm, vector-based algorithm. This is the phase. So report, just similar to daily incidence reporting process, and then automatically AI model structure free text, and we provide recommendations. So let's get started. Okay, so this is basically a simplified version of incidence reporting, because this is a proof of concept system. So we are not doing anything more fancy than simple process. So for example, I would like to key in this Japanese free text here. So this is a typical reporting on a continuous confusion of sodium 3A 500 milligram, and then it was administered in the stage of being separated by 42 milligram per hour. So you could see that actually there's an error occurred here. So our AI model, the BERT model embedded in the system, has automatically identified name entities here. So for example, from 12 o'clock is already identified as duration. Infusion is the root, and then Solu-Demu 3A is the drug name. Form is the infusion. 500 milligram is the strength amount. Strength rate is 60 milligram, and so on. So our system actually, we know that AI model is not perfect, so we allow a medical user to make changes. So for example, this 12 o'clock. From 12 o'clock shouldn't be like this. This is a minor error here. So you could make changes by yourself at this point of reporting. And as you could see, actually, we could predict what kind of incidents occur already, because we had, well, as we mentioned, we did the intention and factuality analysis here. So the system automatically identified these as a wrong string rate incidents. So because 60, these are the error occurred. And the reporter, if this is not accurate, the reporter could make changes at the spot as well. And then through the reporting structure, actually, we automatically drag JQ learning resources to the user. So at the spot of reporting, the user can look for relevant learning resources. And we also did a simple search function in order to use NLP method to search the most relevant similar incidents happened in the past. So for example, these incidents because it's also related to sodium 3A, that's why it was extracted here, and probably the situation is highly relevant as well, and so on. So this is a simple illustration on how we could possibly use AI method as well as digital tool to help user to learn better. So I guess I might be running over time very soon. So I would just like to conclude my presentation. So I guess I may be biased, but I believe that clinical NLP is a very promising area for healthcare. We can see the increasing trend on publication in terms of EHR-based NLP paper until 2016, because the review paper was published in 2016. But actually, what I wanted to say is that it is actually much more promising in nowadays than before year 2015, because including BERT published in year 2018, actually there are many NLP breakthrough in AI discipline. For example, large language model, GPT model, Google Pathway System, these are all published very recently, but these models has already proven outperformance on multiple standard NLP tasks. So we envision that these kind of AI methodology will be really, really empowering the future of NLP, clinical NLP. These are more suitable or more advanced in terms of understanding human language nuances. So potentially AI computation techniques is advancing. Another possible direction for future study is that it's not just one type of data, because we know that some in clinical context, different types of free text data, they are interlinking with each other. Being able to consider multiple data set in one go and identify the accession as well as time order is actually very important to provide information to what you are intended to predict. So potentially we could explore multiple heterogeneous data sources in clinical context, not just incidence report or not just clinical summary. Other direction is annotation efficiency, because we develop our own gold standard data. We know that labeling data is very expensive. We need to find dedicated healthcare professional to read the context and then follow our rule to identify the gold standard data. So we also exploring a more algorithm way. How could we use algorithm to make annotation more effective? Other direction, including improving the knowledge base, argument knowledge base in terms of the ontology structure. So we, in the end, we want to identify signals that are more relevant and credible with respect to what you are interested to predict. So potentially you could add different assertion rules or temporal order into the annotation method in order to more accurately tell the situation on what you're interested, or expand part of speech tagging, not just noun. You could tag verb or adverbs and so on as well. So I guess important success factor, I guess it is share corpora. It's important to allow other AI modeler to learn from a gold standard data so that we could potentially achieve better outcome. The fit between system and user, in the end, we hope that what we design in a digital tool context is actually helping the user, as well as is seamlessly providing decision support or providing learning resources to the user. So it is important to evaluate the fit between them. One important success factor, as I mentioned at the very beginning, this is not one people work. I'm just presenting on behalf of our team. It involves clinical practitioner, it involves policymaker to tell us what is important in terms of in a more high level direction. It involves clinical researcher to help us make annotation. And even though the annotation method we develop, we are working very closely between medical professional as well as NLP researcher in order to identify the rules that is able to communicate between the user and model. So co-creation is an essential approach. As I mentioned, if you are interested, please feel free to take a look on our patient safety website. This is interdisciplinary approach, and these are our research partner, including university partner, JQ, Tokyo U, Kyushu University, Nagoya University. We also use industrial effort as well. So we partner with industrial partners, including data artists, as well as IR linguistic technology to speed up our work. Last but not the least, I'm also interested in dashboard design because my core interest is in digital health innovation. So since the beginning of the pandemic, we have been launching this Japan Life dashboard for COVID-19, and we use our Shui-Yee platform to provide interactive live update on COVID data. If you've got a chance, please feel free to see us, check our information. And I guess thank you very much for your kind listening. I hope I'm not overrunning too much, and feel free to follow us as well as check our information from time to time from AI for Patient Safety website. Again, we are very interested to establish collaboration with NCCHD as well as clinical partner, because one of our upcoming research direction is to evaluate the proof of concept digital tools that I just showed you. We will need some clinical advice as well as potential evaluator to help us achieve our task. So I'm far more than happy to get connected with you. One more minor last point, but not the least. So our university we organize open campus from time to time. If you are interested to join our public health school, please feel free to join us in the upcoming open campus on 16th of October. Prior to our introduction to the school, we have actually organized an open seminar on public health context, global leadership on global health policy direction. So these are our speaker. Thank you very much for your kind participation, and I'm happy to answer any question you may have.
All right. Dr. Zoe, thank you very much. This is really fascinating topic. You know, it's good to hear this because I learned a lot of new concepts and a lot of new things. So I think I can ask the participants if anybody has any questions. So please feel free to ask Dr. Zoe. It's a great opportunity. So does anybody have any questions? Okay, so in this case, I have plenty here that I wrote actually because I found this so interesting. So, I mean, probably the thing that I was considering now is about the kind of discovery process and the usage between different languages. So you mentioned that the model was trained on Wikipedia, so the Japanese Wikipedia, and then it could, you know, start making the predictions and discovering kind of the knowledge and the entities. So how does it work to adapt this to other languages, let's say German or Spanish?
Okay, that's actually a very challenging question. But with our past 3-4 years experience, actually we learned a little bit about that. Okay, honestly speaking, okay, right now, I think up to 3 to 2 years, we have multi-language model that is scale that has already scaled for different languages. But prior to that, for example, BERT was published in year 2018. BERT was originally only focused for English because it was pre-trained with English Wikipedia and so on. But actually, for example, in Japan, we have dedicated NLP researcher. They use the original BERT and then pre-train BERT into using Japanese Wikipedia and Japanese Shinbun, so the newspaper news report. So these kind of pre-trained model learn from particular language. Actually, they are also publishing it in GitHub, and that's why it enable other researcher to make use of this kind of pre-trained model for the subsequent tasks. So, for example, our model was built based on the Japanese pre-trained model. So in Chinese context, German context, they are doing the same thing. Local NLP researcher, they use the state-of-the-art model, pre-train it with their own language, with the large corpora, so that the model itself is scaled for the language usage. But again, these days, some model has already breached the boundaries between language differences, because the model itself is large enough, it has been learned from different languages already.
I see, this is amazing. I mean, language is the kind of ultimate barrier. So it's interesting. This is something that I was also wondering. What are the resources necessary to train a model this big? Is it like supercomputer or GPU, or how do we train this thing?
So okay, that's a good question, and our group has our own server, but our server is too small to train a really large model. But for example, even though our large pre-trained model, we just need to dedicate like a day or two to pre-train the full learn from the full corpora. We use Google Colab. We use our own server to do this. But in terms of an even larger model, even more complicated prediction, you might be using HPC, high-performing computing resources. So actually, researchers in Japan, they are very lucky. They have the potential to access to HPC from different joint universities like Todai, Nagoya. These main national university, they have their HPC resources, and they call for proposal from time to time. So for example, I got an idea, I really want to use these resources. I could apply for the proposal so that if I get funded, I could use the resources to train my model. So this would be one way. Fugaku, Riken, They have a very famous heavy computing power. Potentially, we could access to it with proper administrative process as well. But yeah, I guess we are focusing. Our problem actually is not that large because there are a lot more larger problem than we have. So we have been using our own server as well as Colab to complete the task.
I see. Yeah, that's something that I imagine that it would probably require like some big resources to train a network this big. But then it's interesting, and it's good to know that to kind of actually pre-train for your domain, for your model, can be like locally. These are good news.
Yeah. So for example, one of our researchers, we have been investigating active learning approaches. So we found that actually the clinical BERT, which is a BERT version that is pre-trained by mimic dataset, the largest English discharge summary open source dataset. So clinical BERT is published already. So we use clinical BERT, and we found that the performance is amazing in terms of like name entity identification. So these kind of resources actually enable subsequent researcher to do a lot more. Like if you publish your nice data set or nice model, actually it could potentially really useful for subsequent research.
I see. So for the participants, does anybody have any question for Dr. Zoie so far? So something that I was wondering is about the disease domain. So for example, are these models kind of specific for diseases like diabetes or cardiovascular or hematology diseases, or are they kind of general in the sense that they learn from many different patterns? Take into account kind of the different disease-specific terms?
Yeah, so yeah, that's a very good question, and that really like important direction as well. So you could train model for generic purpose, but if you are hoping to answer a question that is more disease specific, most of the time you will need to identify rules or identify ontologies that is suitable for the disease topic, because in the end, it depends on what kind of relationship, what kind of name entities you identify in the very beginning. So if your direction is just, okay, I want to find out all the drug-drug interaction events from my historical node. So these can be just very generic. You might just find a list of structural interaction pair, and then you try to train up the model. But you could specify it to particular types of drug, and then you need to identify some more drug-specific context in order to train up model to do that. Yeah. Right. So yeah,
I see. So I think maybe a last question for me. After your talk, I was thinking that this opens some very exciting research possibilities, for example, to aggregate patient-specific data. So, for example, if a patient has certain mutations, like some SNPs, which makes them more sensitive to some drugs, is there any research going on in this direction to kind of aggregate like physiological data or genetical data to make the system kind of personalized medicine and identify like, oh, for this patient here, this dose of the drug might be too much?
Yeah. So this is actually a more personalized medicine question. My understanding is that it is not really using NLP too much. So far, what we right now at this point of time is more on using structured item instead of really extracting too much information from the free text. But that's also the reason why I've been mentioning NLP is very promising in medical domain, because as I mentioned at the very beginning, most of the information actually carried in the free text format, and most of them actually are not registered in the structured format, and it depends on the individual EHR structure as well, right? So in the end, hopefully we could like in a way NLP method to develop common data model to extract free text information in a more common data structure, so that it could enable this kind of personalized medicine approach. But so basically my understanding on this direction is we need to bypass the bridge with the gap between free text and structured item. Once the free text item becomes structured, then subsequently, basically, you just design rules as well as maybe design sophisticated method to learn from mass amount of data in order to find out, okay, patient with similar background information, similar comorbidity, similar age, BMI, so on. What is the likelihood on having certain outcome if they take this medicine? So I believe actually this is a gap right now. So we need to bridge the gap between the free text format to a more structured format. Then you could further use a larger number of data set in terms of enabling this kind of study.
I see. I understand. Very interesting, very good. I can see the importance of this gap. So with all that said, if the participants have no questions for Dr. Zoie now, is it okay if people contact you for collaboration or for further questions later?
Yeah, of course.
Okay.
Yeah. I'm here in Tokyo. I'm happy to see anyone. Yeah. Even online or face-to-face meeting.
Great. Thank you very much. We really appreciate it.
Mm.
So with all that said, to the participants, if you want to watch again, please go to our library on YouTube or our internal NCCHD library. And I want to thank Dr. Zoie. Thank you very much for, this wonderful presentation. I learned a lot of new things today and hope to see you in person some of these days.
Yeah. Thank you very much, likewise, for your kind invitation. It's my great honor to be here today.
Okay. Thank you. Bye-bye.
Thank you. Bye-bye.